Okay, Unit 9 test review over inverse variation and rational functions. Okay, on the first problem, this is going to be about inverse relationships. Now, the main thing to really make sure you remember here is that you've got two equations. You've got your k equals x times y, and then you also have y equals k over x. And then this k, this represents your constant. So this problem says, Betty makes a total of 200 cookies for the school party. If M represents the amount of cookies each student receives and N represents the number of students, write a function that represents the inverse relationship. Now here, they already gave us the k, so they already took two numbers and they multiplied them. So for this equation, I would have 200 over the number of students, which is n represents the number of students, and then that would tell me how many cookies each student would receive. Now the other way to write this would be m times n equals 200. So both equations are good. The second one, it says the time it takes you to get to campus varies inversely, okay, as your driving speed. Averaging 20 miles per hour in bad traffic, it takes you 1.5 hours to get to campus. How long will the trip take averaging 60 miles per hour? So the first thing I want to do is I want to find my k, and I do that by multiplying x times y. So the two things I'm going to multiply here are going to be 20 and 1.5, and that gives me 30. Alright, so now that I know what my k is, I'm going to now write my equation. So I've got two choices. I can write it as 30 equals x times y, but I'm going to use the y equals 30 divided by x. Now it says, how long would the trip take averaging 60 miles per hour? Well, that 60 here is my x. So 30 divided by 60, and that gives me 0.5 or 30 minutes. And it makes sense. The faster I'm able to go, the shorter amount of time. So as my speed goes up, the minutes go down. Alright, the next one says the number of revolutions made by a tire traveling over a fixed distance varies inversely with the radius of the tire. A 16-inch radius tire makes 100 revolutions to travel a certain distance. How many revolutions would a 12-inch radius tire require to travel the same distance? So again, I'm going to find my k first. So k equals x times y, which equals 16 times 100, which equals 1600. So my equation would then be k equals, that should be changed. My k was the 1600, so here instead of the k, I'm going to put 1600 equals x times y, or y equals 1600 divided by x. Now here, the x would represent the 12, so 12 would be your x. So 1600 divided by 12, I'm going to go get a baby calculator. So 1600 divided by 12, and that gives you 133 1/3. So 133 1/3 revolutions. Alright, the next one, it says assume y varies inversely as x if y equals 8 when x equals 2. Find x when y equals 2. So here again, I'm going to find the k because I need to write my equation. So k equals x times y, which equals 2 times 8, which is 16. So again, I have two choices in my formulas. I have 16 equals x times y, and I also have y equals 16 over x. Now what they really want to know is, what's x when y equals 2? Okay, so for this one, I can just substitute in here. I think I'll use this one. So 16 equals x times the 2. Now I'm going to divide by the 2, divide by 2, so x equals 8. Alright, the next one, does the data in the table below represent an inverse relationship? If so, what is the constant of variation? So the most important thing here is to make sure that when you multiply both of these, that you always get the same thing. So for instance, if I do 36 times 50, I get 1800. So if it's an inverse relationship, every single time I multiply, I should get 1800. Now I notice that you just flip these two, so that's definitely also 1800. Alright, 6 times 3 is 18, then add the 2 zeros, that's 1800. But let me check the last one. And then here, 75 times 24, and that's also 1800. So yes, it is inverse. It is an inverse relationship, and then my constant k would be the 1800. So if I wanted to write an equation for this, I could do y equals over 1800 over x, or I can even say 1800 equals x times y. Alright, now we're going to start getting into our functions. It says the graph is a translation from the graph of f of x equals 5 over x. Write an equation for the new function. Now, I'm going to take the 5, because that still has to be part of it. I'm going to name my function g of x. Now, what I'm really looking for is how the asymptotes moved. For here, the asymptotes start at x equals 0, y equals 0. But here you can notice they changed. So I noticed the asymptote moved over to 1, and that's where x equals 1. So I know that one of the asymptotes, the vertical one, is x equals 1. Okay, and then the horizontal asymptote actually moved up 2. So y equals 2. That's my horizontal asymptote. Alright, so once I have these two pieces of information, I can come over here. So that vertical asymptote, because it equals 1, I need this to equal 0 at the bottom, so it's going to be an x minus 1 because it moved to the right. And then it's going to be a plus 2 because it moved up. Alright, on the back, it says what are the transformations in asymptotic restrictions on the function of f of x equals 1 and then x minus 4 plus 2. So here, for this one, I'm going to have x equals 4, because that's what makes it undefined. 4 minus 4 is 0. Alright, and then this will actually represent my vertical asymptote. Alright, and then this one here, the 2, that means that it went up 2, okay? So my horizontal asymptote would be y equals 2. Okay, so this moved right 4 up 2. Now the restrictions, you pretty much just take the asymptotes and that's just what they can't be. So for the restrictions, I would say that x can't be 4. And if x can't be 4, that means that y can never be 2. Alright, for the next one, again, I'm saying what are the transformations and asymptotic restrictions on the function. So here, I can tell this moved to the left 3. So left 3. And then this went down 6. So down 6. Now, here would be x equals negative 3 for the vertical asymptote. Okay? And this is my horizontal. And this would be y equals negative 6. And again, that's my horizontal asymptote. And again, notice here, negative 3 plus 3, that's what gives you that 0. Okay? Alright, so that means that for my restrictions, I would have x cannot be negative 3 and y cannot be negative 6. Alright, on the next one, this would actually just be for pre-AP. So here, what I'm looking at is function notation for the transformations. So notice here how it says x plus 5. So that means that it's actually moving to the left 5, and that affects the vertical asymptote. So x equals negative 5, and that would again be for the vertical. This one too would also be for the vertical. It moves to the right 2. So x equals 2. Now, this affects the horizontal asymptote, so plus 7. So this actually moved up 7, so up 7, so y equals 7. And this also affects the horizontal, so down 4. So y equals -4. Alright, on number 13, it says write a function with a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 5. So they don't really say anything about the stretch or compression, so I am just going to just use a 1 on top, so it's neither a stretch or compression. And then it says x equals 0, so that means I'm just going to have an x. And then for the horizontal asymptote, it says y equals 5, so plus 5. The next one says write a function with a vertical asymptote at x equals -2 and a horizontal asymptote at y equals 3. So again, I'm just going to do f of x. I'm going to use the 1 on top just because it doesn't say anything about a stretch or compression. Now, be careful here. This is what I want it equals 0. So here I'm actually going to put x plus 2 and then plus 3. Alright, the next one says, what is the domain of the function? F of x equals 5x over x squared minus 25, and write it in interval notation. So on this one, you're trying to look to see which x values would make this denominator equal 0. Okay, so I can tell that if I do 5 squared minus 25, I get 0. But also, if I do -5 squared minus 25, I also get 0, because a negative times a negative is a positive. So this is really 25 minus 25, which is 0. So this is what I need for the domain. So my two x values would be x, -5, and 5. So this is what it cannot be. So when I do my domain, I'm going to say, in the interval notation, I'm going to say that it goes from -infinity to -5, that's my first asymptote, and then it's going to go from -5 to the second asymptote at 5, and then it's going to go from 5 to infinity. Okay, let's look at the next one. Alright, on 16 it says for each graph state the transformation applied to the function f of x equals 1 over x, again that's your parent function, and it says write an equation and state the domain and range. Alright, so for the transformations, again, it's all about moving from the parent function. Now, the parent function, its asymptotes are at x equals 0 and y equals 0. So here is your vertical asymptote. Okay, that is going to be where x equals 0, and this is where y equals 0. So the transformations are all about moving the asymptotes from the parent function. So I can tell this one, I can draw it here. And the reason I can draw it here is because this is where it approaches, but it never touches. Even though it looks like it, it'll approach it, but it'll never touch it. And that's where x equals -2. So I have a vertical asymptote at x equals -2. And then I also have a horizontal one right here because it didn't move. And then my horizontal one is at y equals 0. Alright, so I need those pieces of information for the equation. So if I write the equation, I'm just going to use the 1 that they have. So I'm going to call this g of x over 1. And here it says -2, so this needs to be x plus 2. And then because you're not moving it up or down, you just stop there. That's all you have. If you were moving it up and down, you would have like a plus or a minus here. Alright, for the domain, I need all the information from the vertical asymptote because that's my x value, and that it can't be, and the domain is all about the x. So on this one, it doesn't tell me how to write it, so I'm just going to do it as a sentence. So all real numbers except -2, and then for the range here, again I need this one, so all real numbers except 0. Alright, on number 17 I can tell this one moved up and down. So on this one, it looks like it's you can draw a vertical asymptote right here. Again, the curve will approach it, but it won't touch it, even though it's kind of looking like it really won't. And then here, it moved up to right here, okay? So this is my vertical asymptote, and that's at 3. Okay, so x equals 3. I need that for my domain. And then here, I've got y equals 2, and I need that for my range. And I also need it for the equation. Okay, so for this one, let me actually go back to this one because I didn't state the transformation. So really the only thing this one did is it moved left 2. Alright, now this one did something a little bit different. On this one here, it moved 3, or right 3. Okay, and it also moved up 2. Okay, so to write the equation again, I'm just going to call it g of x. So g of x equals, I'm going to use the 1 from there. Okay, and now it moved to the right, so it's going to be x minus 3. And then it also, oops. Okay, and then it also moved up, so I'm going to put plus 2. Okay, as far as the domain and range goes, let me make sure you understand that's the horizontal asymptote. Alright, so for the domain, again, I'm going to write in a sentence. So all real numbers except here, because remember, that's the line that it can approach but not touch. So all real numbers except 3. And then the range is all real numbers except, and this is the highest and lowest it can go, so 2. Okay, on this one again, all you're really doing is you're graphing the asymptotes and then just sketch the curves in. So for this one, I can tell that the asymptote is going to move right 4 and then up 3. So everything starts from 0, 0, okay? So I'm going to move this asymptote to the right 4. So that's right here. Okay, so there's one of the asymptotes. That's the vertical. That's where the x equals 4. Okay, and then it says up 3. So I move it up 3. 1, 2, 3. And that's my horizontal one at y equals 3. Okay? And then this is the x equals 4. Okay, and then I'm just going to sketch my graph. Don't worry about points. We're just really making sure you can move the asymptotes. And there it goes. Okay, on the next one, you can tell this goes to the left. So left 5, and then this is down 6. So again, I'm going to move the asymptote left 5. There's my vertical asymptote. Okay, that's x equals 5. I'm sorry, negative 5. And this went down 6. So right there, that's where y equals negative 6. And then again, I'm just going to kind of just sketch them, just as long as you kind of have an idea of where they are. Alright, on the next one, you're going to write the domain and range for the following 3 functions in interval notation and as a sentence, and then for which value of x is the function undefined. Now, this word undefined, y'all, that's when the denominator equals 0. Okay, so for this one, the first thing I'm going to do is I'm going to look for the domain. Now, the domain is all the x values, so I'm going to focus down here. Now, I want to make this equal 0 because that'll give me my asymptote, which will affect my domain. So for this one, for the domain, the asymptote here, you would have to have x equals negative 2. So basically what that then means is that the function for the domain, it can't have a 2 in it. So if I write the domain, I'm going to write it as a sentence. So all real numbers except negative 2. Now, for the range, I need to go back and look at those special rules. Notice how this is a squared down here, and notice there's no degree up here. So really I have degree 0, and I have degree 2, and when I do that, notice that the larger degree is on the bottom. So when it's on the bottom, just like this one, it's y equals 0. So that would be my horizontal asymptote, and I'm going to I need that for my range. So here, this would be for my vertical asymptote, and then my horizontal asymptote would be y equals 0. So I already used the vertical one to help me with my domain. Now I'm going to use this to help me for my range. So for the range, it's going to be all real numbers except 0. All right, the next one. I noticed, okay, so I'm going to start with my, down here, oh, whoops, I forgot to do this part. For what value of x is the function undefined? So again, it's all about making this equal 0 for the undefined, so x can't be negative 2. That's the value that the x is to make it undefined, because negative 2 plus 2 is 0, and 0 squared is 0, which cannot have 1 divided by 0. No, no, no. All right, on the next one, again, I'm going to focus on that vertical asymptote because I need that for my domain. And so x equals 3. Now, the other thing you need to understand is this also makes it undefined because 3 minus 3 is 0, okay? So not only do I need this for the undefined, I also need it for my domain. So I'm actually going to do the domain right now. So all real numbers except 3. Now for my range, again, I'm noticing that my degrees are the same. I have degree 1 over degree 1, okay? So 1 over 1. Now they're the same. These are the same. And when they're the same, I'm going to go look at my chart. When they're the same, you have to use the leading coefficient. So this started off with 3 over 2, so that was what your horizontal asymptote was, 3 over 2. But here, you'll notice, it starts off as 2 over 1. So if I take this 2 over the 1, okay, that's going to give me y equals 2 over 1, which is just 2. Now, this is what I need for my range, because this is my horizontal asymptote. This tells me how high or how low it can go. So all real numbers except 2. All right, this next one. Now, right off the bat, I can tell that I'm going to have to do some factoring. So here, I'm going to factor this. Still have an x minus 2 on top. And then I need to figure out what two numbers multiply to negative 6 and then add to 1. So it's definitely a 3 and a 2. But I have more positives, so x minus 2, x plus 3. Now, I notice I have a hole here, okay? So because I have this hole, it's going to actually affect my domain and my range. So I'm going to find out what the hole is first. So I know the x part of the hole is that x equals 2. Okay, but then I'm going to substitute it in to find the y part, okay? So if I do that, I have 2 plus 3, because that's what x is. X is 2, so 2 plus 3 is 5. But see how there's nothing left on top? So that's actually 0 over 5, which would be 0. So I actually have a hole at 2, 0. All right, then on this one, I'm going to find out what my vertical asymptote is. So I'm going to see what's left. So my vertical asymptote here would be negative 3. So the vertical asymptote, x equals negative 3. And again, I need that for my domain. So for the domain, I'm going to say all real numbers except negative 3 and the x value of the whole, so and 2. Okay, now for my range. Again, I'm noticing that I have a squared on the bottom and an x on top. So I have degree, see if I can find room to do this. I have degree 1 over degree 2. The degree on the bottom is larger. So since the degree on the bottom is larger, y is going to equal 0. So notice here the whole's the same thing. So all real numbers except 0. Oh, they also want me to write the interval notation. So for the domain here, it would be negative infinity to negative 2, and then negative 2 to infinity. For this one, it would be negative infinity to 0, and then 0 to infinity. On this one here, it would be negative infinity to 3, u, and then 3 to infinity. And then on this one here, it'd be negative infinity to 2, and then the u, and then 2 to infinity. All right, this one would be a little bit different, especially for the domain. So I'm going to write that one up here so I have more room. So in interval notation, I'm going to write it here. And notice I have two of them. So remember, domains from left to right. So I'm going to go from negative infinity to the negative 3, u, and then negative 3 to the 2 here, and then the 2 to infinity. Okay? And then for the range here, it would just be negative infinity to 0, u, and then 0 to infinity. All right, last page. So on this one, they want you to state the vertical and horizontal asymptotes. Okay, the holes, domain and range, x and y intercept. And then they also want you to sketch the graph. So on this one, I'm actually going to divide this so that I can see the asymptotes a little bit better. So if I divide this, x times 1 will give me x, and then x minus 4. Okay, first terms always cancel out. The negative turns into a positive. So here, what I have left now is I just have 2. Okay, so if I were to write this, what I really have now here is I have 2 over x minus 4 plus 1. All right, so for my vertical asymptote, again, it's just right here. So what makes it undefined? 4, because 4 minus 4 is 0, so x equals 4. And then for my horizontal asymptote, it's the 1 right here. And again, you could also use the rule with the leading coefficients. You have the 1 and the 1, because they're both degree 1. And again, when they're the same, you take the leading coefficient. So 1 divided by 1 is 1. Or you could just look right here. Okay, now for a hole, there aren't any holes. For the domain, all I really need is the vertical asymptote. So my domain, I'm going to write it as interval, negative infinity to 4, and then 4 to infinity. And then your range, negative infinity to 1, and then 1 to infinity. All right, for my x and y intercepts, I have to do some substitution. So for my x-intercept, I'm going to do it up here. For my x-intercept, I have to have that x minus 2, that numerator. So x minus 2 equals 0, so x equals 2. So the x-intercept is at 2, 0. Now, for the y-intercept, I'm going to substitute in here. So for the y-intercept, I'll do that up here. That's when x equals 0, so I'm going to substitute in 0 here. So that gives me 0 minus 2 over 0 minus 4. Notice that you end up with negative 2 over negative 4, which is really a positive, and then 1/2. So this will cross at 0, 1/2, and that's your y-intercept. Okay, if I sketch the graph, I'm just kind of looking here. So x equals 4, that's my vertical asymptote. And then y equals 1 right here. And then I'm just going to sketch and sketch. All right, the next one. Again, I'm looking for asymptotes and the holes and everything. Now, I do notice right away I do have a hole because x minus 4 is in both the numerator and the denominator. So I'm going to go do the hole over here. Okay, so for the hole, I have to know what the x is. So it says x minus 4, and I make it equal to 0. So x equals 4. Now, to find the y part of the hole, because remember the hole is kind of like an open point, I want to substitute this 4 into what's left. So what I'm going to do is I'm going to do 4 plus 3 over 4 minus 1. That gives me 7 over 3. So the hole will be at 4, 7 over 3. Okay, so that's all for just the hole. Now, for the vertical asymptote, I take what's left on the bottom. That's what's left on the bottom. So for the vertical asymptote, that's going to be x equals 1. And then I'm just going to use the rules to find the horizontal asymptote. If I were to multiply these, I would notice that I have, this would be squared. It's almost like I would have degree 2 over degree 2. And again, because they're the same, I'm just going to use the leading coefficients, and that'll tell me my asymptote. So the leading coefficient here was just a 1. So it would just be 1 over 1, which is 1. So the horizontal asymptote is at y equals 1. All right, so now that will tell me about my domain and my range. So the domain will be negative infinity to 1, that vertical asymptote, and then 1 to infinity. And then the range, again, I'm looking at the horizontal, because that tells me where we'll have to stop going from low to high. It's going to have to stop at 1, and then it'll pick up and go from 1 to infinity. All right, for the x-intercept, I just take the numerator, x plus 3. Let's see, I'll do the x right here. So x plus 3 equals 0, x equals negative 3. So negative 3, 0, that would represent your x-intercept. All right, and then to do the y-intercept, you just substitute with what's left. So for the y-intercept, I'll do that here. I'm going to use this right here. This is what I'm going to use for the y-intercept. I knew that the y-intercept is when x equals 0. So I'm going to do 0 plus 3 over 0 minus 1. And that gives me 3 over negative 1, which is negative 3. So 0, negative 3. And that's your y-intercept. All right, so to graph it, I'm just going to put my asymptotes and just kind of sketch my curve. I have a vertical asymptote at x equals 1, and I also have a horizontal asymptote at y equals 1. And then sketch. All right, the next one, so same idea. On this one here, I'm just kind of looking for some holes. It's really easy to see them when it's like this. So there's a hole. Okay, so I'm going to do the hole. I'm looking at x minus 3 equals 0. So x equals 3. So again, I only know the x part of my hole. I only know the 3. So now I need to find out what the y is. So I'm going to substitute. So what I'm going to do here is I'm going to substitute for the x. So here I would have 3 plus 2 over 3 plus 5, and that gives me 5/8. So the y part of the hole is 5/8. All right, so to do the vertical asymptote, I'm seeing x plus 5 equals 0. So x equals negative 5. For the horizontal asymptote, again, the degrees are the same. They're both going to be squared, just like this one up here. So the horizontal asymptote will be y equals 1, because the leading coefficients are the same, 1 over 1. Now I have enough information now to do my domain and range. So I'm going to do that up here. All right, so my domain, again, is related to this. So I'm going to write this as a sentence. So all real numbers except negative 5. And then my range is related to the horizontal asymptote. So all real numbers except 1. All right, so to do my x and y intercept, the x-intercept, you just take the x plus 2. So x plus 2 equals 0, so x equals negative 2. And that's my x-intercept. And then to do the y-intercept, I'm just going to substitute 0 to what's left. So what's left is the x plus 2, so 0 plus 2. And what's also left is the x plus 5. So on this one, it would be 0 plus 5, and that gives you 2/5. Okay, so my y-intercept is 0, 2/5. Now let me go back to number 21. I just realized I forgot to do something. All right, so on this one here, the domain and range actually is not going to be correct here because I forgot the hole. So remember, the hole you have an x and a y, okay? Well, the whole can't be part of the answer. So that's actually going to affect what I put here. So on this one, I think I actually got a little lucky because remember domain goes from left to right. So it hits negative infinity and then it goes to 1, but then I also need to make sure I put that 4. I will have to erase this part. So the 1 just gets me to the asymptote, and then from the asymptote into the whole, and then the 4 to infinity. And same thing on the range. I'll need to fix that also, because again, it can't be that y value. So I'm going to say that it's 1 to 7 over 3, and then u 7 over 3 to infinity. I almost missed that. Okay, which means, let me kind of show you where the hole would be. So it'd probably be somewhere around, and my graph's probably not all that good. I probably should have made that come down a little lower, but there'd be a hole somewhere about right there. So remember, that's kind of like an open dot. Alright, so on this one right here, let me make sure I don't make that mistake again. I'm going to do the asymptotes first. So x equals negative 5. Okay, so that's my vertical asymptote. And then I'm going to have 1 at y equals 1. Okay, and then there should be a hole at 3. Kind of hard. 4, it's about right here. And then 5 over 8. I'm thinking this graph may look a little different. So it'd be somewhere around here. Okay. Let's take a look at this one. Oh, actually, let me write the domain. On this one, I'm going to say all the domain, all real numbers except negative 5 and 3. Remember, don't forget about the x part of the whole. And then for your range, all real numbers except the 1 from the horizontal asymptote and the 5/8 from the whole. Alright, okay, last one. Okay, I notice here, guess what? I have to factor. So I'm going to factor here. And I have a feeling if I'm having to factor, I'm probably going to find a hole. So what two numbers will multiply to negative 8 and add to negative 2? So I'm thinking it's 4 and 2. But see how I have more negatives here? So this needs to be a negative. And then that means this would be a positive. Okay. Down here, what two numbers multiply to get negative 6 and to negative 1? I think it's probably a combination of 3 and 2. I have more negatives, so x minus 3, x plus 2. Alright, so you can kind of see where the hole is here. Okay, so the hole is at x plus 2. So I'm going to cross those out, and I'm going to find my hole. Alright, so x plus 2 equals 0. X equals negative 2, and then I'm going to substitute that negative 2 in with what's left to find the y part. So negative 2 minus 4 and negative 2 minus 3, that gives me negative 6 over negative 5, which is 6 over 5. Okay? Alright, so my hole is at negative 2, 6 over 5. Alright, now I'm going to find my vertical asymptote. Again, that's what makes it undefined, so I'm looking at the x minus 3 equals 0, x equals 3. So there's my vertical asymptote. I think I'll just draw it right now, somewhere there with the line you can't see. Okay, and then I'm going to find my horizontal. Notice that the degrees are the same. So again, I'm taking that leading coefficient, 1 over 1, which is just 1. And right there. Alright, so on this one, if I were to graph this, I'm thinking this one probably is going to look a little different. I think it's maybe somewhere over here. Let's actually take a picture. Let's see what it's going to look like. Like, so this one, if I were to graph it, I would have x squared minus 2x minus 8. And this one I would have x squared minus x minus 6. Let me make sure I delete all that. Okay. Let me just double check that I have it typed in right. Looks good. Graph it. Okay, so there's an asymptote. Actually, that may be the curve. There's the curve. So it looks like this one's kind of a reflection. Let me kind of get back to the normal picture. Okay. Alright, so there it is. So it's here. And then it just kind of goes over there. Kind of approaches it, but doesn't touch it. Alright. And then again, you have that hole at -2. So your hole's probably somewhere around there. Alright, now let's see, what else do we need to do? We need to do the domain and the range. Okay, so for the domain, it's going to be all real numbers except here and the x part of the whole. Okay, and then the range will be all real numbers except the horizontal asymptote at 1 and the y part of the whole, so 6/5. Okay, the last thing I need to do is the x and y intercept. So for the x-intercept, again, I just kind of take the numerator here. So for the x-intercept, x minus 4 equals 0, x equals 4, so 4, 0. And then for the y-intercept, I'll do that down here. Substituting 0 for x for what's left. So 0 minus 4 and 0 minus 3. That gives me -4 over -3, which gives me 4 over 3. So this one crosses at 0, 4, 3. And again, this is a sketch. I mean, you can tell that my x-intercept is about right. I mean, it's maybe a little off. And then my y-intercept, it's almost there. It's about right. Okay, that's about it. I hope that helps you. Just really kind of go back, and I would just really make sure you can do all of these solidly. And good luck.